So as I was mentioning, we use this gravitational slingshot effect, sometimes it's called, and the reason that this works so well is that we basically don't have to put as much fuel on a spacecraft if we're very clever about using this, and less fuel, less cost, basically, of sending these spacecraft to various parts of the solar system. So asteroids and what are called meteoroids are these generally rocky, although to be quite honest with you, we find situations where we found asteroids that start to almost resemble comets, or it's just anyhow. Comets tend to be more like icy material, usually frozen water and dust. All right. Anyhow, this is an example of a large asteroid, one of the large ones. There's like three large ones: Ceres, Vesta, and Pallas. This one happens to be about 500 kilometers across. Notice it's not exactly spherical. That's because there's not enough mass to make a nice perfect sphere. But these asteroids tend to be almost potato shaped in some cases. And notice they've been hit by other asteroids and other meteoroids. A meteoroid is just basically a smaller chunk of asteroid. Stuff that results from the collisions of these asteroids. And you can see that on the surface of this. This asteroid Vesta has been visited by a spacecraft, and this spacecraft has orbited Vesta for a while and took really nice close-up pictures of it. All right, so before we could only we'd barely make these things out in our telescopes. We knew it was an object in the solar system because it moved with respect to the background of stars, but we certainly didn't have, our telescopes are not powerful enough to be able to see this kind of detail. It was only a mission, spacecraft getting very, very close to this thing and orbiting it and taking lots of pictures, and then radioing the pictures back to Earth. So comets, as I mentioned before, are icy material. They tend to come from the outer part of the solar system. They do have some rocky parts. Generally, the rocky parts are at the center of the comet, the nucleus of the comet, and then there's icy material that is surrounding the comet. And really, that's what the tail is when the comet comes in towards the sun. So it's usually an extremely elliptical orbit, so that it spends most of its time really, really far from the sun, well out beyond the orbit of Mars. Most comets, not every comet, but most of them that we know of, spend a lot of their time way out beyond the orbit of Mars, and then when they sweep in towards the sun and they get close to the sun, some of them closer than the Earth to the sun, but once they get around the orbit of Mars or closer, what happens is that ice goes directly from being a solid, right? Because and then it actually doesn't even make the transition into liquid form. It goes directly from a solid to a gas, and that is well known in physics. It's called sublimation, and that's really what you're seeing that when you look at the tail of a comet. Basically, part of the comet, which was the ice, has sublimated off, and it leaves a nice trail. And sometimes these trails can be like 1,000,000 kilometers or more in size. And really, what's the reason that we can see them is really just the light of the sun reflecting off of them. Okay, it's not giving off its own light or anything like that. All right, so that's comets. Of course, probably the most famous comet. This comet is McNaught. There was a comet back in the 1990s called Hale-Bopp that nobody even knew it existed, as a matter of fact, and it turned out to be one of the brightest comets in recent history. Some comets are certainly out there right now. We don't talk about it. Generally, the general public doesn't talk about them because they're not bright enough to see with the unaided eye. If you have a powerful enough telescope, you can look and find comets all over the solar system. Probably the most famous comet, of course, is Halley's Comet. Halley was actually a contemporary of Isaac Newton, so you're talking about going back about 300 years. The reason Halley's Comet is named after him is because he, using Newton's laws of motion and Newton's law of universal gravitation, was actually able to predict when Halley's Comet would come back, the comet that's now named for him. And he actually worked out what the orbital period is, which turns out to be about 75 to 76 years. So it's roughly one human lifetime. A very famous person that I'm sure you've heard of, Mark Twain, was actually born when Halley's Comet was arriving in the 1800s, and then passed away in I think it was 1910 or so, and he actually knew about that and talked about it, wrote about it, that he was born when Halley's Comet was visible, and then he was very being Mark Twain's sense of humor, he was perfectly happy to leave when the comet returned. And then, of course, Halley's Comet returned most recently in 1986. I was actually in the Navy back then and got to see Halley's Comet from my ship out in the middle of the Pacific Ocean, and it was quite spectacular. The next time it'll come in, I think it's 2061 or so. So hopefully you'll get a chance to see that. All right. Here is a close-up of Pluto. We actually sent a spacecraft just recently within the last 10 years or so that flew by Pluto and took some extraordinary pictures. We had no idea what the surface of Pluto looks like because it's just too far away for our telescopes to make out any detail at all. I mean, there was, it's basically the pictures of Pluto that you have from even like the Hubble Space Telescope is just a few pixels across. This is much more detailed. It's kind of funny to see this kind of heart shape, this lighter colored this surface feature on Pluto. There's a guy named Clyde Tombaugh in the 1930s who actually discovered Pluto. And of course, back then it was considered a planet, the 9th planet, and now of course it's been demoted to just being called a dwarf planet or a minor planet. And it's even more. A better classification of it is to call it a large Kuiper belt object, which is anything beyond the orbit of Neptune. All right. Anyhow, this heart shape is actually called. Remember, Clyde Tombaugh was the guy that discovered it. Is called the Heart of Tombaugh. So it's kind of named after him. All right. So. Let's see. These different colors very much baffled us, and still we're still kind of figuring out what these different colors are on the surface of Pluto. We Pluto's so far from the sun, we really didn't expect to see a lot of geology, but you can see there's cracks, there's mountains, tiny mountains compared to like the mountains on the Earth, but they're still mountains, and these different colors, which are just different substances, different chemical substances that make up these colors. All right. We've actually visited Venus. The former Soviet Union sent their Venera spacecraft, a series of them actually, from 1970 to 1978. They actually landed on the surface of Venus. Venus is a terrible, terrible place as far as spacecraft go. Again, it's got a very thick carbon dioxide atmosphere, and the density of the atmosphere is really, really, really high, about 100 times more dense than that of the Earth at the surface of Venus. And so when these spacecraft landed on Venus, they lasted, just a matter of minutes before the electronics just couldn't handle the high density and the extreme temperature. Venus has what we would call a runaway greenhouse effect. That thick carbon dioxide atmosphere has trapped the heat so that the surface of Venus is hotter than if you turned your oven on broil, right? And you let it come to temperature. It's actually hotter than that on the surface of Venus. So that doesn't do things with electronics don't do very well in that kind of temperature. So these spacecraft gave us, there's a few pictures of some rocks, but that was about it. In more detail, in the 1990s, the United States sent up the Magellan orbiter. So this thing did not land on Venus, but it orbited it over a number of years, as you can see here, and gave us an incredibly detailed map using radar. So the radar is able to go through the thick atmosphere and gave us the surface, which turns out to have mountains and volcanoes, which we didn't see any active volcanoes, but we do think that in recent history, that is, the last few million years, that there were active volcanoes on the surface of Venus. All right, again, more about this stuff in detail when we get to the chapters on these. Of course, we've been landing spacecraft on Mars for a long time, since 1976, which there were actually 2 Viking spacecraft that landed in different parts of Mars. More recently, in the 1990s, there was what's called Pathfinder, and then, of course, the rovers, Spirit and Opportunity, and, of course, Curiosity. Let's see. I think just recently, and depending on when you listen to this, it might have already landed. There's another spacecraft, another rover that's destined to land on Mars and do some more exploration. Because one of the things about Mars is we think that a long time ago, in the early part of the solar system, there was liquid water on Mars, which might have indicated the formation of life on Mars, but we're still investigating that. All right. Of course, the outer parts of the solar system were first explored by some spacecraft called Pioneer, and in the 1980s, the Voyager spacecraft. In fact, the Voyager spacecraft are the only spacecraft to have passed by. They didn't even orbit them, but Uranus and Neptune. They just flew in 1986. The Voyager 2, that is, flew by Uranus, and then in 1989, Voyager flew by.